All right, so now we are entering into our 3D geometry, and we're going to start by working it with surface area. So first, surface area is the measure of total area an object occupies, or another way to think of it is the sum of the areas of each surface on a shape. So, yeah, that we're finding areas of each face and adding them together. That's what we're doing. So we're going to find the surface area of three shapes. We're going to start off with the cylinder. And so with the cylinder, you have your bases, which are circles. Should be an I. Our height is the length of the perpendicular. So length of the perpendicular segment. By the way, from here on out, perpendicular is going to be an upside down T. Accelerated knows that, but I don't think we've introduced that to regular Math 8. Segment that joins the bases. So in this case, right there, that would be the height. All right, and then the lateral surface is the curved surface. So in that case, that is all of this all the way around. So if you're actually looking at a cylinder, it's the space in between, whereas the bases are your two circles. So if we think of a cup, the opening of the cup and the bottom of the cup are our bases, and the walls of the cup would be our lateral surface. All right, so how do we find the surface area of a cylinder? Well, where'd my pin go? There it is. Surface area will equal, or just S equals, but I always put SA. The area of a circle. Sorry, I'm trying to read my notes at the same time. Plus the area of the circle, right? Area of the circle, area of the circle. And I misspelled circle there. Plus our lateral surface. All right, so area of a circle is pi r squared. So we have pi r squared, and then my lateral surface would be 2 times pi times r times h. So 2 pi r would be the circumference around the base of my circle, and then h is the height. That's how we find that lateral surface. Now, we got to know that r is radius. That's half of our circle from the center to the outside of our circle. And h is that perpendicular height. Now, instead of writing pi r squared twice, there's two of them. So now we're going to think of surface area as 2 pi r squared plus 2 pi r h. And this will be our formula we'll use from here on out. So, first problem. Example 1, what is the surface area of the cylinder? Use 3.14 for pi, round your answer to the nearest tenth of a square foot. So, I need r and h. Now, here's the thing about surface area, volume, all of these formulas. All we need to do is find the variables that we have to then figure out what we don't have. So right now I know that I have a diameter. That's a big thing. I have a diameter of 10 feet. I don't want diameter though, I want radius. And so I'm going to take the diameter and divide it by 2 to get my radius. And so my radius is going to be 10 divided by 2, which is 5. My radius is 5 because I only want half of this. That becomes my r. My height is this 2 feet. From here we just plug in surface area equals 2 pi, radius is 5, so 2 pi 5 squared plus 2 pi times 5 times our h, which is 2. Now I like to work everything out and then multiply by 3.14 in the end. So 5 squared would be 25. So here we have 2 times 25 times pi plus 5 times 2 is 10 times 2 is 20. So 20 pi. And then I'm going to do 2 times 25, which is 50. So we have 50 pi plus 20 pi. And then because these both have pi's, like terms, I can combine them. 50 plus 20 is 70. So right now I'm at 70 pi times, so that's going to be the same as 70 times 3.14. Now, why do I wait till the end to do pi? And it's so that, first off, I don't have decimals running through my whole problem. And secondly, especially if it tells you to use like the pi key, you're having to round at some point, which makes it less accurate. So I wait to multiply by pi until the end. So when I take 70 times 3.14, I get approximately 219.8 feet. And then because it's an area, it's going to be squared. So that is our answer, 219.8 feet squared. And so that's how surface area of a cylinder works. Find your R, find your H, go through the problem, like plug and chug. That's the best I can tell you. You substitute in the values and you solve for your surface area. All right, next video we'll talk about the surface area of cones.